Time feels like the most obvious thing in the world. It is there when the alarm goes off. It is there in the shadow moving across a wall. It is there in the quiet certainty that yesterday is gone and tomorrow has not arrived. We live as if we are carried forward on a current we cannot stop, passing from moment to moment, collecting memories behind us and possibilities ahead of us. And yet, according to modern physics, that feeling of flow may be more like a story the mind tells than a feature built into reality itself. The passing of time, the sense that the present is steadily replacing the past, might not be written into the laws of the universe. It might be written into us. If that sounds strange, consider how quickly intuition breaks down when we look closely at the world. Earth feels still, but it is spinning and orbiting at immense speeds. Solid objects feel continuous, yet they are mostly empty space. Light feels instantaneous, yet it takes minutes to reach us from the sun. Again and again, science has shown that the world we experience directly is not the world as it is. Time may be the next and perhaps the deepest example. In everyday life, time seems like a universal background. It is the stage on which everything happens, moving forward at a steady pace. But in fundamental physics, time is not so stable. It behaves differently depending on how fast you move, where you are, and how gravity shapes the space around you. And at the deepest levels of theory, time sometimes seems to disappear entirely, as if it was never part of the script. To understand why, we have to start with a simple fact. Physics does not have one unified definition of time. In classical mechanics, time is an absolute parameter, the same for everyone everywhere, ticking uniformly no matter what happens in the universe. In that framework, time is like an invisible metronome, and the equations of motion describe how systems change as that metronome ticks. But the early 20th century shattered that picture. In Einstein's relativity, time is not universal, it is personal, tied to motion and gravity. Two observers moving relative to each other do not share the same measure of duration. Two clocks placed in different gravitational fields do not agree on what 1 second means. Time dilates, it stretches. It becomes part of a larger structure called spacetime, where space and time are woven together. Relativity does not say that time is an illusion. Clocks still tick, people still age, but it changes what time is. It turns time from a universal river into a coordinate, something like a direction in a four-dimensional geometry. In that geometry, what counts as now depends on the observer. There is no single, global present that all of the universe shares. This is where the everyday idea of time begins to wobble. If there is no universal present, then the idea that the universe is unfolding moment by moment becomes harder to define, unfolding according to whose now. If two observers disagree on which distant events are happening at the same time, then simultaneity is not a fundamental feature of reality. It is a relationship that depends on perspective. Quantum mechanics introduces a different tension. In quantum theory, time usually enters as an external parameter, much like it does in classical physics. The famous Schrödinger equation describes how the quantum state evolves with time. But the theory also contains something that seems timeless at its core. A quantum system is described by a state, and measurements give probabilities. The before and after of measurement, the emergence of definite outcomes, and the role of observation raise deep questions about whether time is truly fundamental or whether it is part of the way we describe processes from the outside. And then comes the biggest problem of all, combining quantum mechanics with general relativity. Each theory is extraordinarily successful in its domain. Quantum mechanics governs the microscopic world. General relativity governs gravity and the structure of spacetime. But when physicists try to unify them into a single framework, time becomes a problem to be solved, not a foundation to build on. In some approaches to quantum gravity, one of the central equations that is meant to describe the universe at the most fundamental level does not contain time in the usual sense. Instead of something evolving from one moment to the next, the equation describes a static relationship, a constraint. It looks less like a movie playing and more like a complete image, one that already contains everything. Some physicists argue that this is a clue. Perhaps time is not a basic ingredient of reality. Perhaps time is emergent, like temperature. Temperature feels like a property of an object, but it is not fundamental. It emerges from the collective motion of countless particles. On the microscopic level, there is no single thing called temperature. There are only particles moving and colliding. Temperature is a useful, powerful description that appears when you look at the system in bulk. In theoretical models, time might be similar. What we call time could emerge from deeper, timeless relationships, patterns of correlation, structure, and information. The universe might not run in the way we imagine, it might simply be. This leads to one of the most unsettling ideas in modern thought, that past, present, and future may all exist at once. In relativity, spacetime is often pictured as a four-dimensional block. Every event, every conversation, every supernova, every heartbeat has a place in that block. Events are not constantly coming into being and then vanishing into the past. They are coordinates in a structure. From this perspective, the universe is not a story written line by line. It is a book that is already complete. This is sometimes called the block universe hypothesis. In the block universe, the flow of time is not something the universe does, it is something we experience. The universe does not unfold, it simply contains. To be clear, the block universe is not a theory that adds new particles or forces. It is an interpretation, a way of understanding what relativity implies. If there is no universal present, then it becomes natural to treat all events as equally real, regardless of where they sit along the time dimension. What we call the future is simply a region of spacetime we have not experienced. What we call the past is a region we have. In this view, time is a dimension rather than a process. It is like space. We do not think that space flows from left to right. We simply exist at a location, and other locations exist too. The block universe suggests that time might be like that, a landscape, not a river. But if all events exist, what about change? What about motion? What about the feeling that reality is happening right now? Here the block universe offers a subtle answer. Change may not be a fundamental feature of the universe. It may be a feature of perspective within the universe. A human being is not a point moving through time. A human being, in the block picture, is an extended pattern in spacetime, a world line. Different slices through that world line correspond to what we call different moments of a life. From the inside, it feels like moving. From the outside, it is a structure. Motion becomes a relationship between parts of the block. A planet's orbit is not something that must be generated moment by time as flow. It is a curve in spacetime. The dynamics that we describe with equations can be reinterpreted as geometry, the shape of paths through spacetime, constrained by physical laws. This does not make physics any less predictive. It does not change the fact that if you let go of a cup, it falls. But it changes the kind of explanation we imagine. Instead of a universe pushed forward by time, we have a universe whose entire pattern is consistent. Still, even if such a picture is mathematically elegant, it collides with human experience. We feel a present moment. We feel that the past is fixed and the future is open. We feel that we move through time. So the question becomes unavoidable. If time may not be fundamental, why does it feel so real? Part of the answer lies in how brains work. The mind is a system built to survive. It does not present reality as it is. It presents reality as it needs to be for an organism to act. One of the most useful things a mind can do is organize experience into a sequence. What just happened? What is happening? What might happen next? Memory is not a passive recording device, it is an active reconstruction. We do not store the past as a perfect archive, we store traces, patterns, associations. The brain continually updates a model of the world, using the immediate present and the stored past to predict the near future. That process creates a powerful sensation of flow. because the brain is always comparing what it expected with what it received and updating accordingly. In that sense, the present may be less like an objective slice of the universe and more like a workspace in the mind, a brief window in which information is integrated into a coherent experience. What feels like now is a cognitive construction shaped by attention, perception, and the limits of neural processing. Cause and effect deepen the illusion. We experience the world as a chain. One event leads to another. A match is struck, then it ignites, a glass is dropped, then it shatters. That ordering is so consistent that it seems like a law written into time itself. But in physics, causality is not always tied to a universal clock. In relativity, causality is tied to the structure of spacetime. What can influence what depends on the speed of light and the geometry of spacetime, not on a single shared now. Events are ordered by whether a signal could travel between them, not by a global present moment. Then there is entropy, the concept that may do more than any other to explain why time feels like it has a direction. Entropy is often described as a measure of disorder, but more precisely, it is a measure of how many microscopic arrangements correspond to a macroscopic state. High entropy states are those that can be realized in many ways. Low entropy states are special, constrained, rare. The second law of thermodynamics tells us that in an isolated system, entropy tends to increase. Not as a moral rule, but as a statistical fact, there are far more high entropy states than low entropy ones, so systems naturally drift toward them. This provides an arrow of time. We remember the past, not the future, because the past is associated with lower entropy conditions that allow records to form. A photograph, a fossil, a brain's memory trace, these are physical records, and record-making processes depend on thermodynamic asymmetry. The future does not leave records in the present in the same way, not because the future is unreal, but because the conditions for record formation point in one direction. According to modern physics, the fundamental laws at the microscopic level are often nearly time-symmetric. Many equations work just as well forward as backward. Yet the world we experience is not symmetric. Eggs scramble, but do not unscramble. Smoke spreads, but does not gather itself back into a cigarette. This everyday irreversibility is deeply connected to entropy. So it is possible that what we call the flow of time is tied to the flow of entropy, an emergent direction arising from statistical behavior and special boundary conditions, like the universe beginning in an extraordinarily low entropy state. If that is true, then our sense of before and after is not a fundamental feature of the laws themselves, but a feature of the kind of universe we happen to inhabit. And if the sense of flow is built from memory, prediction, and entropy, then a more radical suggestion comes into focus. Time may be, at least in part, a feature of consciousness. This does not mean time is imaginary in the trivial sense. Pain is real, hunger is real, color is real. But these things are real as experiences produced by physical systems. Color, for instance, is not a property of light alone. It is a relationship between light and the visual system. Different organisms carve the spectrum differently. What is red is not a universal category written into nature. It is an interpretation built by the brain from electromagnetic signals. In a similar way, the present might be the brain's way of carving a usable slice out of the world's information. The feeling of moving through time might be the brain's way of tracking change, linking cause and effect, and maintaining a coherent identity across many moments. In theoretical models of a timeless universe, what exists fundamentally might be a network of correlations. This state is related to that state. This configuration is compatible with that configuration. From within such a network, a subsystem like a brain could interpret certain correlations as memories, others as anticipations, and thereby generate an internal sense of temporal order. The flow would be the story the subsystem tells as it navigates a static structure. If time does not exist as a fundamental ingredient, where does that leave us? It leaves us in a strange place, because so much of human meaning is built on temporal ideas, beginnings and endings, choices and consequences, growth and decay. We locate ourselves in time the way we locate ourselves in space. We ask where we are, and we ask when we are. We assume now is something nature provides. But in a universe where all events exist in a block, now is not a special slice shared by everything. Now would be local, tied to a particular observer, a particular brain, a particular state of information. What feels like the present might be an emergent boundary between what is recorded and what is not, between what the mind treats as settled and what it treats as uncertain. This raises philosophical implications that are difficult to settle, and science does not offer definitive answers here. If the future already exists in the block universe, what becomes of choice? Some argue that choice is still meaningful because it is part of the structure. The fact that your decisions have a place in spacetime does not make them less yours. Others find the idea troubling because it clashes with the intuition that the future is open. If time is emergent, what becomes of existence? It is possible that existence is not a sequence, but an eternal state. Not eternal in the sense of lasting forever through time, but eternal in the sense of being complete, containing all at once what we usually spread out across past, present, and future. And yet, even in a timeless framework, the lived experience remains. We still wake up, we still feel anticipation. We still grieve losses and hope for gains. The universe might be a fixed structure, but we are patterns within it that are sensitive to certain directions because our memories and our bodies are built in an entropic world. It is possible that the deepest truth is not that time is either fully real or fully unreal, but that the word time is doing too much work. In everyday life, time means the rhythm of experience, the ordering of memories, the predictability of cause and effect, the ticking of clocks. In physics, time can mean a coordinate in spacetime, a parameter in equations, a measure along a world line, or an emergent quantity arising from deeper structure. We use one word for many related ideas, and then we wonder why we cannot pin down a single essence. Modern science increasingly challenges everyday assumptions, and the nature of time may be one of its most profound challenges. It may turn out that time is not the foundation we imagined, but a model useful, precise, indispensable for describing the world at our scale, yet not ultimate. Some physicists argue that when we finally understand quantum gravity, time will appear the way temperature appears in thermodynamics, real in practice, not fundamental in origin. In theoretical models, time may arise from relationships between quantum states, from entanglement, from information, from the way subsystems compare themselves to others. It is possible that the universe, at its base, does not contain a clock. It contains a structure, and within that structure, certain beings experience sequences. If that is true, then the most familiar feature of our lives, the steady feeling of moving from moment to moment, may not reflect the universe as true architecture. It may reflect the architecture of minds living in a universe with an entropic arrow, building stories from memory and expectation. And so we arrive at a quiet uncertainty. Time may be fundamental, or it may not be. The equations may one day settle the matter, or they may only deepen the mystery by showing us new ways to describe reality without the thing we thought we could not live without. But even now, we can hold the possibility gently that the flow of time is not something happening to the universe, but something happening within us, as we trace a path through a reality that is stranger than intuition. Perhaps the universe does not move from past to future, perhaps it simply is. And perhaps what we call now is not a point the universe reaches, but a perspective we inhabit briefly, vividly, and without ever seeing the whole.